the triangle congruence theorems and postulates that we've done so far. How do you prove triangles congruent? SSS, ASA, SAS, AAS. Okay, so far we've done those four. Okay, we said very specifically there is no donkey theorem, right? We don't swear at the teacher. Don't swear at anyone, but for sure don't swear in math class. ASS does not exist. So if you see that, so far we've said disregard it, it's not a thing. Today I'm kind of gonna renege on that a little bit. But you still won't swear at me, okay? You still won't swear at me. Let me first show you why there is no donkey theorem, okay? Look at these two triangles. There's something called the hinge theorem, where if I have a triangle that looks like this, and I swing this edge over, I could put it here, and I would still have the same length side, and a 45-degree angle. So angle, side, side, and angle, side, side, which is true. Those things are congruent, but those triangles are not congruent, which is why there is no donkey theorem. There is no ASS theorem, right? But this is different when a right triangle comes into play. In a right triangle, okay, there are different pieces to it. Are you with me right now? I feel like some people are playing games and looking at other things on there. Take notes with me. There is what's called the hypotenuse. Do you know why this side is the hypotenuse? It's the longest side, and it's where? It's across from the right angle, okay? So the longest side will always be across from the right angle, but it will always be the longest side of the triangle, okay? That's the hypotenuse. The other two sides, the sides that form the right angle, right? So this side and this side that form the right angle, those are called your legs, okay? Now, donkey theorem says angle, side, side, which doesn't work. But because it's a right triangle, we can make it work. We call it the hypotenuse leg triangle, or the HL theorem. In order for the HL theorem to work, I'm going to prove it to you why it does work in just a minute, but you still need three things. So there's only two letters, right? H and L, but you still need three things for this to work. The three things you need are, you need congruent hypotenuses. Has to be that one hypotenuse is congruent to the other hypotenuse. You need congruent corresponding legs. Congruent corresponding legs. And you have to know that you have two right triangles. And that's the one that doesn't show up in the H and the L, right? But because it's an H, a hypotenuse only exists in a right triangle. So if you're going to use HL, we have to know that we have right triangles, so we can say the hypotenuses are congruent and the legs that correspond are congruent, okay? Let me show you why this works. The only reason this works with a right triangle is if I extend this leg, okay, and then I measure so that this is congruent to this. So let's say I turn this into a triangle where those two legs are congruent, okay? I also know then that this side is reflexive on those two triangles. And then here's where the right triangle part of it comes into play. This is 90. What's this? A right angle, okay? This is the only type of triangle where if the one is a certain measure, the other has to be the same measure, because 90 plus 90 equals 180, right? It forms a straight line. So if you look at this setup, I can say these two triangles are congruent right now by SAS, meaning that these are then congruent by CPCTC. So if I have these three things in right triangles, I can say HL is true. So really HL is SAS extended, okay? It's just not going to look like SAS. Which also leads to this good point. If I have these two triangles, and those are my markings, I'm still proving those two triangles congruent by SAS, right? I don't know anything about the hypotenuses here. So a right angle doesn't mean it has to be HL. You can still use SAS with right angles because we know all right angles are congruent, right? But something to be aware of. Okay, so considering all that, take a look at this setup. Are these triangles congruent?
Yeah.
Why? Not SAS. HL, right? You have a leg congruent to a leg. You have a hypotenuse congruent to a hypotenuse. And you have right angle and right angle. So we would say, yes, these are congruent by hypotenuse leg. Because we can say all three things that we need. Right triangles, congruent legs, congruent hypotenuses. Okay? Okay. So, yeah. Let's do some proofs. There's only two. They're pretty quick. Oh, it flipped all my stuff again. Why is it doing that? Oh no, it's just switching where my bar is. For some reason, my bar keeps dropping to the bottom of the letters. I don't even know how that's possible. Those should all be on top, not on bottom. Sorry. Okay, in a proof like this, let's look at what they're telling us. It says segment WJ. Remember, we want to mark everything we know. Segment WJ is congruent to segment KZ. Then it says WJ is perpendicular to KZ, so that's a right angle. And it says JK is perpendicular to KZ. So that's everything they told us in the given. We're trying to prove that triangles are congruent. So where is this going to go in our proof? The very last step. We're going to say triangle JWZ is congruent to triangle ZKJ. Okay. What's my first step going to be? The given. Everything we know right here because it's been given to us. Okay, so now think about this. Our end goal is to say that these two triangles, this one and this one, those two triangles are congruent. That's our end goal. What do we know about those two triangles that has not been given to us? JZ. So I can say JZ is congruent to JZ. Why? It's reflexive. I can just tell you, JZ has stood the test of time because I started teaching this like 17 years ago, and people always like, oh, JZ, and you still do it. He's still there, huh? Yeah. All right. So look at your setup. Okay. Now, we said in order to prove triangles congruent, come back to me. I'm sorry I talked about JZ. In order to prove triangles congruent, we have to know that we have two right triangles. Is that what they told us in the given? No. What did they tell us in the given? They're perpendicular. Okay, so what we have to say is, sorry, not that. We have to say angle W and angle K are right angles. How do I know that W and K are right angles? The definition of perpendicular, right? They told us in the given that they're perpendicular. So the definition of perpendicular is that two lines form a right angle. So now we know they're right angles. Okay, now here's where people are always like, what? We already said they're right angles. That's not what you need to prove triangles congruent by HL. You need to know you have two right triangles. Okay, so we know now we have two right angles. Now we have to say triangle JWZ and triangle ZKJ are right triangles. not right angles, okay? We already said right angles. Now we have to say the right triangles. And the reason for that one every single time will be the definition of a right triangle. This one always comes after we have said we have right angles, okay? So if we've said we have right angles, then we know we have right triangles, because the definition of a right triangle is a triangle who has one right angle, right? Okay, so we have proved 3 things. We have proved we have right triangles. We have proved we have congruent hypotenuses. And we have proved we have congruent legs, right? They gave us the legs. We did reflexive for the hypotenuses. And we used the perpendicular to get us to 2 right triangles. So looking at those markings, you have a hypotenuse with a hypotenuse, a leg with a leg, and we have the right triangles, so the triangles are congruent by HL. Oh, what happened to my, you guys? That's hideous. This is supposed to be triangles. What happened?
I was thinking, I was like, I don't know where results from.
Yeah, just draw a line here. Yours has it?
Yeah.
Oh, you know why? Yep. I changed something earlier on and it messed up this stuff. That's right. Yours is good. Mine's just hideous. Okay. Do you want to try this one on your own? It's a very similar flow to what we just did. I think you should try it. Try it. Look, we've got 7 minutes. You should try it.
That's not all.
That's a lot.
No, I don't think
Give it a go.
Finish it.
You can.
Come on, Grant.
I believe in you. Use the one that we just did. It's very similar. That can be your guide. See if you can come up with it all. 5-step proof.
Bless you. Thank you so much.
Anyone think they've got it? Feeling confident? What'd you do for step 1? Given. So all of this stuff right here, because it's been given. And then mark what you know, right? CD congruent to EA. And then it says AD is the perpendicular bisector of CE. What does that mean? What does that tell us? Okay, I know why you said that. But it says AD is the bisector of CE. So CE is the one that's getting bisected, right? So just be careful with that. I get it. It's a little tricky. If we're bisecting CE, it's actually these two that are congruent. So CB is congruent to BE. Why is that? Definition of a bisector, right? If it's cutting it in half, then those are equal parts. So that's definition of a bisector. What else do we know? So we used this. What about this? What about that perpendicular? What does that tell us? Before right triangles, they're right angles, right? The fact that it is perpendicular means, and this one's annoying because you have to name it with 3 letters, ABE and angle CBD are right angles. Okay, how do we know they're right angles? This thing, right? Perpendicular. It's the definition of perpendicular. Okay, so now we have right angles. And we have congruent hypotenuses. And we have congruent legs. But we need one more thing. Right angles lead us to right triangles. So now we say triangle CBD and triangle EBA are right triangles. Why? Every time. Definition of a right triangle. Can I tell you the most common mistake I see made on that step? People say definition of a right angle instead of definition of a right triangle, okay? This should always be a triangle in your reason. Okay, a right triangle has one right angle, and that's what we said in the step before, that we have right angles. So you're good there. What's your last step? HL. Triangle CBD is congruent to triangle EBA by HL. We have hypotenuses, we have legs, and we have 2 right triangles. HL. Okay, so your quiz tomorrow is a proof that can go through anything including HL. So HL, SSS, SAS, ASA, AAS, right? CPCTC. When do you use CPCTC? Sides and angles after you've said triangles are congruent, right? Yeah, I think this will be the best one because you're most familiar.